In this mathcast, we show how to use GeoGebra to do linear programming. Let's assume that we have a problem with the following constraints. X is greater than 0, y is greater than 0, 10x plus 20y is less than 140, and 0.6x plus 0.8y is less than 7.2. Our objective function, which we need to maximize, is v equal to 0.4x plus 0.6y. How do we do this with GeoGebra? We open GeoGebra. The first two constraints that say that x is greater than or equal to 0 and y is greater than or equal to 0 means we are working in the first quadrant. So we move our drawing pad down to the first quadrant. Now, GeoGebra does not do inequalities. So the second thing we do is type in the third constraint, but using inequality. So we have 10x plus 20y, and now instead of less than or equal, we type equals 140, and we hit enter. And there's the line, and GeoGebra has reduced the equation to its simplest form. We use our mouse scroll button. We put our pointer over in the drawing pad, and we use our mouse scroll button to back up till we can see the whole thing, and we can move again down to the first quadrant. So here we are with our first line. Let's make it red. Now we need to know which side of the line to shade. So we test a point not on the line. Let's test 0, 0. Substitute is 0 plus 0 less than 140. Yes, so we're going to shade the side of the line down here by 0, 0. So let's put our points in. We need intersection points for here. We would need that anyway for here. And because we're going to use this part down here, we'll take 0, 0. We're going to rename that point O. So we're in the first quadrant. We want this part. We get our polygon tool, and we go from O to A to B and back to O again. That's our first area that we have. Going to make this area red and turn off all the labels. Now our fourth constraint is also in an inequality. We click down in the input bar here, and then we type in 0.6x plus 0.8y, and we can't put inequality, so we put equal 7.2 to get the line. There's our line. We're going to make it blue. Now the fourth constraint, we substitute 0, 0 and find that it satisfies the inequality. So this line is also shaded down towards 0, 0. So we need the two intersection points here and this point. So we take our intersection tool, find that intersection point, this intersection point, and we make a triangle using O, C, D, and O again. We make this blue and turn off all the labeling. And now we can see that our combination area is this quadrilateral down here. Let's get this point here. So we need to check A, E, and D in our objective function. The easiest way to do this is in the input bar. So we're looking at V with A in it, and we're going to, we have 0.4 times x value of the point A plus 0.6 times the y value of A. Now before we hit enter, we're going to copy this. So we press shift and home and control C, and then we hit enter. So the value of the objective function at A is 4.2. Now we're still down here in the input bar. We click control V. We change this to be at E. So we put E here, E here, and E here. Hit enter. So that's the value of the objective function at the point E, and we need it for the point D. So we paste again and put D in everywhere. And hit enter. And we can see that VE is the maximum value. So this is where our objective function is maximum at E. So given our four constraints, we have found that our objective function has a maximum when x equals 8 and y equals 3.